Question 1. So one of the points is an outlier. Write down the coordinates of this point. So when we look at all these points, you can see that the vast majority are just basically sort of going upwards in a positive direction, broadly speaking in a straight line, with the exception of this point here. So this one is the exception to the general rule. This is a one-off. This is the outlier. So what are its coordinates? Well, that's 10 along the corridor, 19 up the stairs, so 10, 19. Now for part B, for all the other points, write down the type of correlation. Well, broadly speaking, these are all going upwards in a positive direction, so that's called positive correlation. If they had been sort of generally speaking going downwards and broadly speaking a straight line, that would have been negative correlation. Now on the same day in another British town, the maximum temperature was 16.4. Estimate the number of hours of sunshine in this town on this day. Now for one of these estimates, what you must do is put in a line of best fit, and that's what I've done here in green. So you get a ruler, and by eye you just try and put a line through all of these points, ignoring the outlier, just so as many points are on one side of it as are on the other. So it's sort of straight down the middle really. Now there's bound to be, everybody's lines of best fit are going to be slightly different as it's being done by eye, and that's built into the mark scheme. You'll see the mark scheme allowed anything between 12 to 13. So using my line of best fit, I take my 16.4 maximum temperature, go along and hit my line of best fit, go downwards, and I get an answer of 13. But as I said, anything between 12 and 13 was allowed. Now for part D, a weatherman says temperatures are higher on days when there is more sunshine. Well, we can see that's true. As the number of hours of sunshine increases, so does the maximum temperature. Yes, this is true, as the majority of points for high temperature appear when there are more hours of sunshine, or something to that effect, something to acknowledge the positive correlation. Question 2. So express 56 as the product of its prime factors. So you break down this 56 into any two numbers that multiply by 50 to make 56, for example 7 times 8, and I've then circled the 7 because that's a prime number and I can't break that down any further. And moving over to the 8, I can break that down into 2 times 4, with 2 being a prime number, and that's therefore circled. And I can further break down the 4 to being a 2 and a 2. So my final prime numbers are 2, 2, 2 and 7. So write those down as your answer. You must include the time sign between each of them because this is a product. A product means when things are multiplied together, and I think it's just helpful for the marker if you put it in numerical order. Question 3. So I think with these some sort of grid method should be used really, so you're showing all your workings. You can use Napier's method, that diagonal method, which is good, or alternatively you can just use a normal grid method. So this is the way I like to do it. First things first, I just want to get a ballpark answer for what I should be looking for. So just as an estimate, 54.6 is roughly 50, 4.3 is roughly 4, so I know my answer is going to be roughly speaking 200. So what I then like to do is to use my grid method but ignore the decimal points. So just do 546 multiplied by 43. So that's what I've done here. A 500, a 40 and a 6 multiplied by the 43 being a 40 and a 3. And then you just fill in the grid cross multiplying. So 40 times 500, 4 5s are 20, add the 3 noughts. 40 times 40, 4 4s are 16, add the 2 noughts. 40 times 6, well 4 6s are 24, add the 1 nought. 3 times 500, 1500. 3 lots of 40, 120, and 3 lots of 6 or 18. And then finally I've just got to add up these 6 numbers here, which is what I've done over here, to get 23,478. So those are all the correct digits in the right order, but where do I put my decimal point? Well, I know my answer's got to be about 200, so clearly it's got to go in there after the 4. So my final answer is 234.78. Question 4. So don't get too bogged down with the algebra here. What you've got to show, just focusing on the area of maths that we're talking about. And here we're talking about the area of a square. So how do you work out the area of a square? Well, of course, it's just the base times the height. Now the base is 3 plus x, and it's a square, so of course the height is also going to be 3 plus x. So we know the area is base times height, 3 plus x plus 3 plus x. That gives us the area, and what is this area? Well, we're told that it is 10. So we have constructed our own equation here, which we now need to go on and rearrange. So multiply out this pair of brackets, so 3 times 3, 3 times x, x times 3, x times x, to give us this. Gather like terms, so gather up those x's in the middle, and then I've just popped it in a different order, so I've got my x squared plus my 6x plus my 9 equaling my 10. Take away take away 9 from both sides, and that gives me x squared plus 6x equaling 1, which is what I had to show. So I just asterisk that to show, there you go, I'm finished. I've shown what I needed to show. Question 5. So we've got to work out the total weight of the metal frame. So really to start off with, we're going to have to work out how many meters we've got of this metal frame. So obviously we've got this 12 and this 5, another 12, another 5, and then finally we've got this diagonal bit of metal. Now to work out that length, we're going to use Pythagoras, just looking at this triangle here. Base of 12, height of 5, and the diagonal of x. So we know from Pythagoras that the hypotenuse squared, so x squared will equal 12 squared plus 5 squared. So that's 144 and 25, which is 169, and the square root both sides, so the x is the square root of 169, which is 13. So this length here is 13. So how much framework have we got? We've got a 5, a 12, a 5, a 12 and a 13. Add those all together and that gives us 47 meters. Now we're told the weight per meter is 1.5 kilograms. Well, we've got 47 meters, 1.5 kilogram per meter, so we need to do 47 times 1.5. So that's one lot of 47 and half a lot of 47, which is 23.5, so that's 70.5 kilograms. Don't have to do it this way, of course. You could just do 1.5 times 47, and that's going to give you 70.5 as well. Question 6. Now, if we're going to show that these two lines are parallel, we're just going to have to show that both of them have got the same gradient. So remember, for a gradient, y equals mx plus c. The gradient is the number of x's. So this L1 line is already in y equals mx plus c format. Okay, so the work's done for us all here already. The gradient of L1 is 3, and for what it's worth, it would cross the y-axis at -2. Now for line 2, we need to rearrange this to get it into y equals mx plus c format. So starting off with what we're given, let's go and choose and add 9x and take away 5 from both sides, just so we've got the 3y on its own. So we're adding 9x, taking 5 from both sides. So at that point we've got 3y equals 9x minus 5. Well, I don't want 3 lots of y, I want the equation to be y equals stuff. So I'm going to divide both equations, both sides by 3. So that gives me y equaling, well, 9x divided by 3 is 3x, and minus 5 divided by 3 is minus 5 over 3. So this is now in y equals mx plus c format. So my gradient for L2 is 3. So I can see that both my gradients are the same. So therefore these two lines are parallel. So I've said L1 and L2 have the gradient of 3, so therefore they are parallel. Question 7. So, we're told that the mean mark for all the class is 60. So, if the mean of all 10 boys and 20 girls is 60, so if the mean of 30 children is 60, what must be the total mark obtained by all the boys and all the girls? Well, it must be 30 times 60 is 1,800. So just looking at that the other way around, they've got 1,800 marks between them. You divide that by the 30 boys and girls to give us a mean mark for the class of 60. Now, looking at the girls alone, well, we've got 20 girls and their mean mark was 54. So how many marks did these 20 girls get in total? Well, it's going to be 20 times 54, which is 1,080. So this is the total of marks by the boys and the girls. This is the total of marks by the girls. So the total marks by the boys must be this take away this, which is 720. So the 10 boys got 720 marks between them. So their mean mark is 720 divided by the 10 boys, giving us 72. Question 8. So for part A, we've got to write this as an ordinary number. Now, because the power is a minus, we know the ordinary number is going to be very small. So let's sort of set up our workings by popping lots of noughts in front of the 7.97, because I'm going to have to bunny hop in this direction. Now, I bunny hop along 6 places, so take your decimal point and move it along 6 places. 1, 2, 3, 4, 5, 6. And I can see it ends up here. So my final answer has got to have 1, 2, 3, 4, 5 zeros before the 797. So that's my final answer here. Now for part B, I think just to help you gather your thoughts, just pop the division as if it was a fraction. So we've got 2.52 times 10 to the 5 to be divided by 4 times 10 to the minus 3. So think of these first 2 terms being divided and then these second 2 terms being divided. So first of all, let's do 2.52 divided by 4. And I've done this over here using the bus shelter method. So 4's into 2 doesn't go, so carry the 2. And we're at the decimal point mark, so pop in your decimal point. 4's into 25 is 6, carry 1. 4's into 12 is 3. So that 2.52 divided by 4 is 0.63. Now secondly, when we're considering this division, remember when you're dividing, you take away the powers. That's one of the index laws. So 5 minus minus 3 is the same thing as 5 add 3, which is obviously 8. Now this is an answer, but this is not in standard form. Remember, for the answer to be in standard form, the opening number has to be between 1 and 10. So to turn this to being between 1 and 10, we have to choose to multiply this term by 10. So we're multiplying it by 10 to the power of 1. And to offset this, we've got to choose to divide this second term by 10 to the minus 1. So the overall number doesn't change. We're multiplying this one by 10, dividing this by 10, overall no net effect. So 0.63 times 10 is 6.3. And 10 to the power of 8 divided by 10 to the power of 1, well again we're dividing, so we take away the powers. 8 take away 1 is 7. So our final answer is 6.3 times 10 to the 7. Question 9. So we're told that Jules has to pay £600 after the 20% VAT has been added. What is the price of the washing machine with no VAT added? So let's think, the way I like to set this out, have your 3 columns. So you've got the original price, the price change, and then the final price. And we're adding 20% on to the original price. So set the original price as being 100%. We're adding on 20% VAT, so our final price is 120. So how do we get from 100 to our final price? What is our multiplier? How do we get from 100 to 120? Our multiplier is 1.2. Now, we know that our final price, the price inclusive of the VAT, is £600. So we're not going left to right when we would multiply by 1.2. we're going right to left. So we do the opposite, we divide by 1.2. So we've got to do 600 divided by 1.2. Now I think the easiest way to think of this is, let's get rid of the decimal point. Let's choose to multiply both of these terms by 10. So that gives us 6,000 to be divided by 12. I've done that over here using the bus shelter method. 12s into 6 doesn't go, so 12s into 60 is 5, followed by the 2 zeros, so 500. So £500 is the price of the washing machine before the VAT is added. Okay, 500 plus 20% of 500, which is 100, gives us the 600. Question 10. So here we've simply got to multiply out these three brackets. Now it doesn't matter which order you do it in. I've chosen to multiply the second bracket by the third bracket to start with, and I've done this over here as a side working. So x plus 2 multiplied by x plus 3, x times x is x squared, x times 3 is 3x, 2 times x is 2x, 2 times 3 is 6. Gather up your x's in the middle, you get x squared plus 5x plus 6. So these two terms here multiplied together are x squared plus 5x plus 6. So now that's got to be multiplied by the x plus 1. So again, just think of your clause going across. So it's x times each of these three terms, and then plus 1 times each of these three terms. So that gives me x cubed plus 5x squared plus 6x plus x squared plus 5x plus 6. So that's a single x cubed, gathering up my x squared. So I've got 5 of them here, 1 of them here. So that's 6x squareds. Gathering up my x's, I've got 6 here and 5 here. So that's 11x. And then my plus 6 on the end. So my final answer, writing it in this form, is x cubed plus 6x squared plus 11x plus 6. Question 11. So write down the coordinates of the turning point of the graph. Now the turning points are either the maximum or the minimum. So with this positive parabola, the only turning point we've got is this minimum point here, the point at the bottom, which has got a coordinate of 1 along the corridor, minus 3 down the stairs. Now, where does our curve, write down the estimates for the roots of f of x equaling 0. So where does our curve equal 0? Well, it equals 0, so where is the y value 0? Here and here. So reading off these two values, we get 2.75 and minus 0.75. Because the function of each of those, when we put 2.75 into the function, into the curve, and minus 0.75 into the curve, we get an answer of 0. We get y equaling 0. Now the mark scheme was quite generous here. It allowed answers for the first one between minus 0.7 up to minus 0.8, and equally you didn't have to get 2.75. It allowed answers between 2.7 to 2.8. Now for part C, this is different. We're now saying we put 1.5 into the function. What y value does that give us? So when we pop x being 1.5 into the function, so 1.5 into the function, what y value do we get? We get minus 2.8. So just be very clear the difference, okay? With part B, we're saying which x values give us a y value of 0. But with part C, we're saying what with an x value of 1.5, what y value do we get? Question 12. So with these indices, really think of it as dealing with the minors first of all, and then dealing with the fraction secondly. So where you've got a minus, this just means you've got to flip the number over. So think of 81 as being 81 over 1 effectively. So to sort out the minors, we have to flip this over, giving us 1 over 81. So at that point we've flipped it over, so we've sorted out the minors, so we're just left with the half. Now a power of a half means we have to square root both the numerator and the denominator. The square root of 1 is 1, and the square root of 81 is 9. So our final answer is a ninth. Now with part B, we don't have a minus involved, so there's no flipping going on. We've just got to deal with the fraction. Now the numerator makes it bigger. That's where here we're going to be squaring. The denominator always makes it smaller, so here we're going to be cube rooting. So we've got to square and cube root. Now you get the same answer doing whichever order you do, but clearly it's going to be a lot easier to go smaller than bigger. So let's choose to cube root the 64 and the 125 first of all. The cube root of 64 is 4, because 4 times 4 times 4 is 64. And the cube root of 125 is 5, because 5 times 5 times 5 is 125. So when we cube root, we get 4/5. That just leaves us then to sort out the squaring. So we have to square the numerator and the denominator. 4 4s are 16, 5 5s are 25. So our final answer is 16 over 25. Question 13. So it's inversely proportional to, so that's going to be k divided by something. Now what is y inversely proportional? It's inversely proportional to the square of x, so it's y equals k divided by x squared. Now had this said y is directly proportional to the square of x, our starting point, our opening formula would have been y equals k multiplied by x squared. But this is inversely proportional to the square of x, so our opening provisional formula is y equals k divided by x squared. Now we need to go on and work out what k is, so we can take any pair of values we like to sort this out. I'm going to just take the one we're starting with, so I'm going to work out k when x equals 1 and y equals 9. So x equals 1, so we've got y 1 squared and y equaling 9. So 9 equals k divided by 1, so k must equal 9. Our constant is 9, so we can rewrite this provisional formula now knowing that k equals 9. So our formula, our equation, is y equals 9 divided by x squared. Now for part B, we're being asked to use this to find the positive value of x when y is 16. So y is 16, so 16 equals 9 over x squared. So if we multiply both sides by x squared and divide by 16, we get x squared equaling 9 over 16. If we then square root both sides, and bearing in mind we want the positive value of x, we get 3 over 4, because the square root of 9 is 3, the square root of 16 is 4. Question 14. Now I think this is pretty tricky, but I'll do my best to try and explain it. So, we're told that our ratio of white circles to white squares is 4 to 5. So white circles to white squares is 4 to 5. Black circles to black squares is 2 to 5, and also that our overall ratio of whites to blacks is 3 to 7. So really this bit up here is just repeating what's in the question. Now what I then thought was, right, okay, our whites are 4 to 5, well we've got 9 whites, okay, we've got 9 whites. Now if we want to maintain our ratio of 3 to 7, well 9 to 21 is the same ratio as 3 to 7, because 3 3s are 9, 3 7s are 21. So what can I do to get, given that I've got 9 whites, what can I do to have 21 blacks? Well at the moment I've got 7 blacks. So to turn that into 21, I can choose to multiply both by 3. So that gives me 6 black circles and 15 black squares. So this is my final actual numbers. 4 white circles, 5 white squares, 6 black circles, 15 black squares. So we're still maintaining our white to black ratio of 3 to 7 because we've got 9 to 21. We've still got our white ratio of 4 to 5, and we've still got our black ratio of 2 to 5. So those are my final actual number of shapes in the game. 4 of these, 5 of these, 6 of these, 15 of these. So work out what fraction of the shapes are circles. Well, my circles, I've got 4 white circles, 6 black circles, so there are 10 circles. I've got 4 plus 5 plus 6 plus 15. I've got 30 shapes overall. So I've got 10 circles out of a total of 30 shapes. So a third of my shapes are circles. Question 15. So work out an estimate for the height of the cone. So I'm going to use this formula, but I'm estimating. So my volume, which is 98, to one significant figure, that's 100, equals a third times pi, or pi being 3.1415 ... to one significant figure is 3. My radius squared, well, my radius is 5.13, so to one significant figure, my radius is 5 to be squared, multiplied by h. Now a third times 3 is 1, so those two cancel out. So I'm left with 100 equaling 5 squared times h, 5 5s are 25, so 100 equals 25 times h. Dividing both sides by 25, I've got an estimate for the height of 4. The mark scheme allows anything between 3.5 to 4.5. Now for part B, will your estimate be more than the actual answer? John uses a calculator to work out the actual answer. Is my estimate more or less than my actual answer? Now think about it. My volume is an overestimate, over. My pi and my r are underestimates, so I've got an over equals under times the height. So if I just basically divide through by my two unders, I've got height equaling an overestimate divided by 2 underestimates. So think about it. This is an overestimate, and then I'm dividing by something that is underestimated. So my height is going to be quite a big overestimate. Okay, so you need to say it's an overestimate as the numbers in the numerator have gone up because they're an overestimate, and my numbers in my denominator have gone down when I've underestimated. So words to that effect. Question 16. So really, to kick off here, you've just got to number crunch the algebra and simplify. So let's start off by multiplying out n minus 2 all squared, which is obviously n minus 2 multiplied by n minus 2. So multiplying a pair of brackets, so n times n times minus 2 times n, minus 2 times minus 2 gives us this. Gathering our like terms in the middle, we get n squared minus 4n plus 4. So we've got n squared minus 2 minus our n squared minus 4n plus 4. Now just be careful at this point, this is effectively a claw here. So we've got minus n squared, minusing a minus 4n, so that's plus 4n, and then a minus 4. So people often get this term wrong here. So the n squareds then cancel out because we've got n squared minus n squared, so we're left with 4n minus 6. Now if we factorise that, we get 2 lots of 2n minus 3. Now anything being doubled is by definition even. It's by definition an even number. So having got to this, we can then say 2 lots of 2n minus 3 is always even, as it's a multiple of 2. Question 17. So we've got 7 green counters, 2 blue counters. We take 2 at random. What's the probability that we get 1 counter of each colour? So if we're going to get one count of each colour, we're either going to get a green then a blue, or alternatively we're going to get a blue then a green. So how could we get a green then a blue? Well, to get a green it's going to be 7 out of 9. Then as we pick that second counter, the chances of getting a blue are going to be 2, but because a green counter is now gone, it's going to be 2 out of 8. So make sure you've got that 8 as your denominator. Now alternatively, we could pick a blue and then a green. Well, picking a blue to start with is obviously 2 out of 9, but then getting a green is going to be 7, but out of 8 again because the blue's gone. So just be careful with that denominator, that 8 there and that 8 there. Okay, so then it's just your knowledge of fractions. When you're multiplying fractions, it's top times top, bottom times bottom. So 7 2s are 14, 9 8s is 72 twice. And then we add the numerators, giving us a final answer of 28 over 72, or a simplified version thereof. Question 18. So we're told the gradient of the diagonal dB is a half x plus 6. So bearing in mind y equals mx plus c, that's telling us that the gradient of the line dB is a half. Now we've got to find an equation of the diagonal AC. Now the first thing to take on board with a rhombus is that this diagonal is going to be perpendicular to this diagonal here. So given that the gradient of dB is a half, the gradient of AC must be minus 2. You take your half, you flip it over and change the sign. So the gradient is minus 2. So the line AC is going to have a gradient of minus 2. And what else do we know about this line? Well, it goes through the point A, which is 511. So once we know a gradient and we know a point on the line, to find the equation of the line we can use the formula y minus y1 equals mx minus x1, where m is the gradient, which is minus 2, and x1, y1 is any point on the line, so x1 is 5, y1 is 11. So y minus 11 equals minus 2 multiplied by x minus 5. So multiply out the bracket, minus 2x plus 10. Remember, minus 2 times minus 5 is plus 10. And then if we add 11 to both sides, we get y equaling minus 2x plus 21. Question 19. So, this question is all about the ratio of OC to CD. So I think it would be a good starting point to find the vector from C to D. So I'm going to choose to go from C to X and then X to D, given that XD has been given in the question. So CD is C to X and then X to D. So let's first of all worry about working out the vector CX in terms of vectors A and C. So CX is half of CA, because X is the midpoint of the line AC. So what is the vector CA? Well, the vector CA is a plus A minus a C. So that's what CA is. Now given that CX is half of this, that's going to be half an A minus half a C. So CX is half an A minus half a C. So going back to what we said about CD, CD comprises C to X, which is a half an A minus half a C, and then plus XD, which has been given as being 3C minus a half A. Now what's quite fortuitous here is that half A and that minus a half A cancel out, leaving us with 3C minus a half C, which is 2.5C. So the vector from C to D is 2.5C. So we're talking about the ratio of OC to CD. So that ratio in terms of vectors is the vector c to the vector 2.5c. The ratio OC to CD is the same as C to 2.5c. So effectively dividing through by C, that gives a ratio of 1 to 2.5, or in other words, a ratio of 1 to 5/2. Now we want to have the ratio in the terms of k to 1, so we really need to have the right hand side being 1. So let's just decide to divide through by 5/2, or in other words multiply by 2/5. So this ratio here is the same as the ratio of 2/5 to 1. So given that k is the first number in the ratio, k is 2/5. Question 20. So given this simultaneous equation has two equations, one of which is non-linear, we have to solve this by elimination. So we'll take the linear equation, the simpler one, and make either x or y the subject. So here it's going to be easier to make y the subject by adding 3x to both sides. So our linear equation is y equals 3x plus 13, just rearranging this, and we then go and substitute this into the non-linear equation. So we replace that y there with 3x plus 13. So we have x squared plus 3x plus 13 all squared equaling 25. So that's really the key bit to get as far as this. Now from then onwards we've just got to really number crunch this to solve this. So we multiply out 3x plus 13 all squared, which I've done over here on the right. So 3x times 3x is 9x squared, 3x times 13 is 39x, 13 times 3x is 39x, 13 times 13 is 169. Gather up our x's in the middle and we get 9x squared plus 78x plus 169, which I've got over here. So x squared plus this equals 25. So gathering up our x squareds, we get 10x squared plus 78x plus 144 equals 0. Now just divide through by 2 and we get this, and this factorises. So factorising this, we get to 5x plus 24 in one bracket and x plus 3 in the second bracket. So our two solutions for x are minus 24 over 5 and minus 3. And then if we then take these x values and substitute it into the linear equation, or this rearranged linear equation, we get our y corresponding y values of being minus 7/5 and plus 4. So we're told that AB equals CD, and we're told that angle ABC equals angle BCD, and we've got to prove that AC equals BD. So really we've got to prove that the triangles ABC and the triangles BCD are congruent. Okay, because if they're congruent, then their bases AC and BD by definition must be the same length because they're congruent triangles. Now we're going to do this by way of side angle side, because if we look at the triangle ABC, we can see that this left hand side here is the same length as this length CD with regard to triangle BCD, so those sides are the same. Obviously we're told that these two angles are the same, and then this side here is common to both triangles. You see, for the triangle ABC it's the top left hand side, and for triangle BCD it's the for ABC it's the top right hand side, but for triangles BCD it's the top left hand side. So we can prove it by way of side angle side. Okay, so working our way through that, we can say AB equals CD, this side is equal, that's given. Secondly, moving on to the angle, we can say angle ABC equals angle BCD. That angle is equal, those angles are equal, again that's given. And then the only bit that isn't given is this third side, the side BC, which is common to both. So we can therefore conclude, because we've got side equal, angle equal, side equal, that we can conclude that triangle ABC is congruent to triangle BCD by way of side angle side. and therefore we conclude that the length AC equals BD. So question 22. Now this was a bit of a stinker, I must admit. So let's take our time working through this. So first things first, the first mark was available by giving what the cosine of 30 degrees is. Okay, we're going to be needing to use this later on. We're told that angle ABC is 30 degrees, ABC is 30 degrees, ABC is 30 degrees. So hopefully you've just rehearsed how to work out sin, cos and tan of 30 degrees and 60 degrees by first principles. So just to remind you, to prove what cos 30 is, or you may well have just learnt it, that it's root 3 over 2, but if you haven't learnt it, you just need to very quickly figure it out in the exam. If you have a little equilateral triangle with sides 2, 2 and 2, if we then split it in half, then obviously this angle at the top becomes 30 degrees for this little right angled triangle here. So we've got a hypotenuse of 2, a base of 1, so the cos of 30 degrees, being the adjacent over the hypotenuse, is going to be root 3 over 2. So that was a way to get an opening mark. Right, back to the question. So let's first of all look at the triangle ABC, which I've drawn over here, where we're being told that AB equals BC, and they're both x in length, and we're told that the angle ABC is 30 degrees. Now, using the cosine rule, which is a squared equals b squared plus c squared minus 2bc cos a, we can then conclude that the length AC must be AC squared equals x squared plus x squared minus 2x times x cos 30 using the cosine rule. So, so that's our opening line. So that's simply using the cosine rule on this triangle, where AC is basically our lowercase a, 30 degrees is our uppercase a, b is x, and c is x. Now, from the workings we've done over here, we can then substitute in that cos 30 is root 3 over 2. That's what I've done here. Just replace the cos 30 with root 3 over 2, and then I can just basically cancel out these two 2's here. We're multiplying by 2 and dividing by 2, so they're cancel. If we then factorise, we're left with AC squared being x squared multiplied by open bracket 2 minus root 3. Okay, now, big point, it's obvious when you see it, but you may not have taken it on board. The length AC is the same as the length PQ, so if we're concluding that AC squared equals this right hand side, we can similarly say that PQ squared must also equal this right hand side. So we need to get as far as that. So we know what PQ squared is in terms of x. So let's park that, and then we're now going to go and have a look at the triangle PBQ. Okay, the triangle PBQ. Now, if we rearrange the cosine rule, so we've got the angle as the subject, we get this. So we can now say that cos this angle up here, cos the angle PBQ equals b squared, which is our 10 squared, plus c squared, which is 10 squared, minus our a squared, which is our PQ squared. Okay, so minusing PQ squared all over 2 times b times c, so 2 times 10 times 10. Okay, so that's just using the rearranged cosine rule on the triangle PBQ. So that takes us through to that, and then the clever bit, we replace our PQ squared with the workings we've done over here on the left. So that gives us this line, and then we're nearly there. We then just basically pop this first term and the second term both over 200. So 200 over 200 is 1. We then go and pop this over the 200, and then I've just popped these two terms the other way around, so it ties in what we had to prove. So we're there. Okay, so not easy. So in short, we had to use the cosine rule on triangle ABC, and then we had to use the rearranged cosine rule on triangle PBQ.